Hi, utampen. What if plot is 0 to begin with? That's not the flags that I was looking for. This is map private. I have a private shared. That's it. It's going to be either private or shared, apparently. Not even a combination of it. Right, what are these two? 28 and 0. So file descriptor and offset, I think. Yeah, file descriptor and offset. We have first prod and then flags. Read, write, exec and none. Wait a minute. Yeah, none is gonna be 0, right? Cypher is doing his thing again. Prod read, prod write, map shared. Mon and map shared. Man. Man, oh man, oh man. Okay, value flags is bitwise inclusive or of these options. So we have just shared and private, but they could be odd and even with fixed. Right, okay, so I call this and we get that back, and then I'm writing to this address and it has no problems with it, as it should. Let's do something infinitely more complicated, as in the ABA test. Map test, ABA test. What? Oh, this only the segregated storage is being tested here, of course. Yeah, well. It is annoying. Okay, so I'm passing it to thread functions, but the thing is, it keeps being called as it is. And I'm calling allocate on it. I don't want to do this probably. I'm not sure. From here, it's just called to allocate. Allocate again, deallocate, allocate. Now I suppose I want to replace this thing with a memory page pool. The thing internally has an SSS. And if I call allocate on the memory page pool, then in effect I'm just calling it directly on the SSS. Except of course that now we can't control what lambda we are using. But it's not really a problem. Well, it is a problem in the sense that I have asserts, which I no longer can use then. But I can just store the first, if I store whatever the first call to allocate returns, then I can probably still do those search. And deallocate, yeah, this calls deallocate. So hey, let's try that. And the thing has to be constructed with a block size. This is my partition size. And I could set these two to 4 both. Then I know that it's going to be exactly the same as the array. I think I have partition size defined here. Yeah, that's like quite obviously. What was 16? Yeah, 16. So I have 16 blocks of, sorry, 4 blocks of 16 bytes. And this way we have that again. Now we're not having this, and I'm passing MPP. Let's just forget about it. I just go straight for the it's really switching to the memory page pool. Well, then block data is must be the first and only allocation. Let's call that mapped start. Map base, I think I call it elsewhere. Where's my 1? For the 1 we have head points to A, so probably this is 1. This is the very worst allocation, so I should just store this to well, that is hardly an uncertain. just have to assign my mapped base here. Well, almost per definition, right? Don't have the block anymore. Wait, character pointer map base. That's nonsense. It's a global, so it's 0 already. Okay, so I now successfully replaced this simple segregated storage with a memory page pool. Would be nice if it had compiled. Variable field action 1 declared void. Looks like it has no clue what memory page pool is. Probably should include it. Memory page pool. What? You fix it and you get the exact same error. That is so weird. Well, because there is no memory in front of it. It still doesn't know what it is, because it literally doesn't exist. You know what? Maybe I should just call it memory pool. Memory page pool. And then I'll just define here memory pool being a memory page pool for easy changing it later. And valid conversion from void pointer to character pointer. Equals, here we add something. It should be a character pointer for that reason. Can I compare the character pointer with the void pointer? Yeah, I can. Just assignment is not okay. The APA test. Of course it doesn't work. Yeah, the block size must be a whole number times the memory page size. That is true. My 16 is on the small side there. Oh well, let's increase it. How big is a page these days? And we hang. That's new. Well, that is not nice to debug. Stuff like that. Action 1 is nowhere to be seen. That wasn't even started yet. Oh, leaving thread. Action 1 already left. Okay. I think I know what it is. I know what it is actually. The problem here is that I have my own pointer tag here, and if I don't use that, then it's gonna hang because it opens a gate here. So this gate is never open because I'm not using this. In order to use that, we would have to use this simple segregated storage. And I'm totally not using that. Because I'm using MemoryMappedPool. Which uses its own simple segregated storage. Hello, meme cached. What is happening here? Yeah, I'm coding. Trying to fix the ABA bug in my segregated storage object that is being used in my MemoryMappedPool object. And now I'm wondering if I'm going to duplicate all of this or temporarily make it a template or make it always a template. I don't want to make it always a template. I could temporarily really don't want to copy everything. Probably should do something temporarily. Let's make this a template and then say T, and I pass my own simple segregated storage here. Yeah, and then theoretically, I have to print the type here, of course. The type of the simple segregated storage. I hate that because I keep forgetting how to do that. Type name off. Hey, we have provision for it in the CWDS. So I was trying to remember this, which isn't even that hard to remember. But yeah, it's easier even. this in my debug namespace. It is a character const pointer. It's a function. I'm totally not sure if this includes the debug namespace. Yeah, I think it should, but it doesn't. It is also quite annoying. There are no arguments of type name of that depend on a template parameter. So a declaration of, oh God, it thinks that I'm declaring something. Yeah, well, I'm not. So I think the conclusion is that it doesn't know what it is. Yeah, what the F? I'll just have to tell that the name is debug namespace. So that is namespace debug. That should work. Or not. Still think I'm specializing something. Oh no. Yeah, I made it a template. Never mind. This stuff has to be moved to the header file now. Oh, how annoying. Yeah, okay. Let's think. So I have to think how permanent I want to make this. blocks type. I want to get rid of these white spaces like right now, which make, I think what I'm actually doing here is, well, this is obviously not empty. Well, obviously, there's hardly anything there. Does it match that? Yes, so we are calling this, which is probably responsible for, and or, no, actually this just does something with the standard in and or, yeah, standard error, I don't know. There was a problem with Ninja. You would suspect an SED, right? This one, maybe. No. I'll try to reproduce this. I think the okay, current dear CPUs. Read. Don't need all that actually. Not done, whatever. I'm just gonna go straight to here. If execute this. Yep, empty lines. Okay. Let's just remove the SCD. Also empty lines. Still empty lines. So it looks different though. Totally looks different. But yeah, there's still empty lines anyways. I can hardly imagine that this AWK is doing it. doing it. The empty lines come from somewhere else, unless it is keep. No. Okay, let's try to remove the whole AWK. Looks like that single quote here. Oh, what? What did I do? I think the single quote here is part of the AWK. And the match is just no escape or no. How the hell do I get out of this mode? Can't. Well. Make just use of the mode. Oh no, that doesn't work. What? Delete F quote. There we are. So it writes stuff into our AWK. So what if I don't do that? Still empty lines. Well, hopefully it's not my filter. It totally is my filter. What is this? I think it is an executable. Yeah. So I have somewhere source code that compiled into that. Well, maybe another day. Solution A equals a map base field. Oh, it's not assigned. Put a. This nothing is mapped here. Just nonsensical. I'm not using mapping yet. But it still should work, I think. Okay, let's just step through this very slowly. List. Next. Let's initialize the debugging stuff. Memory pool. What is that going to do? Probably nothing. Step. It stores 4 in the minimum and maximum chunk size. The head tag is set to end of list. This is 4. The other one's also 4. M-chunks reserve. The block size is 4096 bytes, which is 1 time the memory size of this machine. Capacity is 4. We're going to start thread 1. Let's be safe and set a breakpoint on action 1 and action 2, because we're just going to start 2 threads and then join them. But okay, I want to, if we get back, I want to, we'll never get back. Break 116 anyway. Continue. Action 1 is the first one. Yes, that is good. Step. This is the first call to allocate. So this should actually allocate memory now. And we are inside the MemoryMappedPool template with my own SimpleSegregatedStorage object. And we're going to call allocate on that. eventually. There we are. This is indeed, this is not indeed. Wait a minute, where are we now? This is allocate of simple segregated storage. But that's the wrong one. I wanted to use mine. Oh, this is the base. Why is it not saying that it is the base? Oh, yeah, well, okay. Okay, but that is correct then, I suppose. Okay, we're reading the head tag. The head tag was set to end of list. So while head tag is unequal end of list, it's going to be false, and this it should pass this loop. Let me just to be sure print this, and that should be 3. Yep. So we go to past it, reach end of the list. No, we didn't. We didn't. Well, actually, we did, because just the whole list is empty. Okay, and yeah, like literally, the head was set to end of list, so we did reach the end of the list. Try to allocate more memory. No, this is still equal to end of list, so we're going to call add new block. Which is here, I think, yeah. Which then in turn calls allocate on the simple segregated storage. We're going to allocate 4 blocks. That was the intention. And here the allocation happens. So we get something allocated, not virtual memory. That's the same pointer as we called back. So it's just not stored into in map base for some reason. Okay, step. Add block. Yeah, so this is going to this must be 4. And I'm going to have 4 blocks. We're going to have 3, I think, assignments to mnext, just internally. So 4 blocks, so 3 of them point to the next block. And this is node, which is next node, which is last pointer minus partition size. Well, last pointer is already the -1 here, so it's actually pointing to the last block. So this is the second last block, getting its next pointer that points to the last block. That was the third block. So this is then the second block, pointing to the third block. And this is the first block, pointing to the second block. This being the first block, node now must be equal to that pointer. The pointer that we all, oh, this one here, it ends on 2000. Next, and then we're done. Okay, cast this stuff. New head tag becomes something that points to first node here, which by the way is still that value. Load the current head tag, which is still 3. Set the node, the next, wait a minute, what is this? Last node. Last node is going to be set to that head tag, so that's going to be that is now being set to end of list. And then this compare and swap is immediately successful. And now our head tag has become the beautiful pointer here. How do I see, where do we get the head tag from? Here, mhead. Yeah, that is obviously the decimal form of that. For the people who can't read that, I'll show you the hexadecimal value. See? It's, yeah. Next, okay, so now all we did is the head pointer points to newly allocated memory, which in turn was linked as a linked list of 3 blocks. The whole list is now done, but we didn't allocate anything yet. Not sure. Oh, I guess I should do step. Okay, that's quite annoying. We switched the threads. But not this point, of course. Print pp. Head tag is still that value. That looks good. Yeah, the I don't know. I would have preferred, of course, to follow action 1 all the way up till where it stops. So somewhere that went wrong, but I know where it is. You can continue debugging. Enter thread action 2. So this gate has already been opened by action 1. So I do next, it just will pause. Holy moly, what the fuck. Huh? Action 1 is hanging on the destructor of the mutex. This makes no sense whatsoever. Why would this all hang? Thought it would continue running, but apparently not. Okay, so we can still follow action 1 because action 2 is now doing what? Action 2 is now waiting until action 1 reaches the point where I thought it was already, but we skipped it, but it didn't skip it. It just switched threads, whatever. We're back. Okay, so action 1 is now going to again try to allocate more memory, but this time previously we got here and there was entered, but now mmap-ed tag is no longer equal to end of list. So yep, that's the correct value. So this should just return immediately. I'm just going to do finish here. So this is true, so this is false. So we do not do what the if is doing. We are not going to return null pointer because we have memory. We're just going to go to the top and then read head tag again into head tag. So now this head tag has the magic value, and it's no longer equal to the end of the list. So now we go into this while loop, and the head tag is new head tag is head tag next, and that's where we have to stop for the ABA problem to occur. So it's going to stop inside next for debugging purposes. We're now inside the next, which is going to do the following, blah blah blah. First time, yes, wait, and the wait is for it's waiting for the ABA to happen. So this is still true, and fault node is going to be the magic value. Yes, and the second node is going to be almost the same, but a little bit bigger. 3000 if I had to guess. Yes. That is one memory page further, and then we get here. So next, false. Now we let the other thread run, and then we wait ourselves. And the other thread is unfortunately already past my breakpoint. I probably have to set a new breakpoint, otherwise we lose it. Info threads. So let's switch to thread 3. See where it is. Let's go to here. It's 12. So as soon as it comes back from this, I want to catch it. So I need a breakpoint of 135. And we can switch back to action 1. Thread 2. And then just do a continue here, or I probably also want to catch it, right? If it comes back. Let's put a breakpoint here at 42. Wait a minute, if I do that, no, that's not good. Delete 6. That would, the other threads also come here. I want to wait until it returns from this wait. Shit, how to do that? Can I set a breakpoint here? No, I don't think so. Maybe I can do finish or something. Step into the wait and then do a finish, and then hope that still works while the other thread is running. Or I just return here. We follow the other one until it opens this gate, and then I set a breakpoint here. It's probably as easy. So I'm gonna follow 3. Wait, did I already continue it then? I didn't, did I? No, so next. The other thread is not running. Okay. Thread 3. I have a breakpoint here, so I can just continue. Yep. Okay, action 2 is running. Ah, okay, yeah, I get it. Met base is obviously not set. Yet. Yeah, okay, that's kind of stupid. And there's also no way to get to it. Yeah, okay, I get it. But it was good to see all of that anyway. Why not? Quit, yes, VI 136. You have to do it exactly the other way around. This is the first place. So here we have to initialize it. And there tested. Because this one is going to hang. Yeah, this one is the second one. I'm stupid. This is entered the first, but then it hangs deliberately, as in the for the debugging purposes. And then this thread runs and allocates it. Allocates the one that this one is trying to allocate. So that's the A value. So it gets A, and then we put B in the head, and then we put A back, and then we're done. And only then this one starts running again, and then it gets the same A value as this A value. So this A value is the map base, and then here it must indeed be equal to that. Now everything worked. So that means that now I should be able to go to actual mapped. This is not map base. This is just first allocation. But yeah. Now I want to switch to the memory map pool. And I guess replace that one. Into that true. Man, I would hate it, but oh, I hate it. I have to make the memory map pool a template now. Just to replace the segregated storage in it. Nah, unfortunately, is how it is. Could stare long and short, long or short, but yeah, memory mapped pool, which now has to become a template. Just make this an inline file instead. Yeah, whatever. Hello, Williams. My memory map pool is it's not a template. Memory map pool. Oh, just not including the header. Nothing. Oh, right. Yeah, yo. Yeah, I copied stuff. Now I'm trying to use the wrong simple segregated storage. I mean, I made a copy of the simple segregated storage, but I need a map segregated storage now. To the mapped memory pool should use the mapped segregated storage, which I then also have to copy, because you have to change the next thingy. Just put it below here. Mapped pointer tag. You're kidding me, right? Yeah, memory stuff here. Memory SSS base. And then actually I need just to make a copy of the mapped pointer tag. This thing isn't even changed. So much duplication. And then I have to change. Suppose doesn't really matter where we wait, directly after reading mnext or after this line, because this is just local. Yeah, it doesn't really matter. Let's just wait here. So here comes the same as in the previous next. I was like, where are my undefined references? But they are here. Hopefully we can solve that by including memory map test. Yeah, I'm not interested in that actually. Shit. Finally we get to the real stuff. stuff that we did want to fix. Yay, okay. Cross fingers. Core dump. I'm not happy with this. Oh, okay. Okay, well, that I understand. That's what you would expect if the ABA fails. But that should be fixed in this code. So I don't absolutely have no idea what's going wrong then. Oh shit, I forgot to go to my dad.